So yesterday we began talking about relations, and we talked about the domain being all the x coordinates, the range being all the y coordinates, and relation is like the ordered pair. So now we're looking at 6.2, which is equations as relations. So we're still looking at domains, x coordinate input values, and range, the y coordinate output values, but now we're looking at it in an equation. So, solution set. For this definition, I want you to write, the solution set are the set of solutions of the problem. So, the ordered pairs that make the equation true. Okay? And for equation in two variables, I'm just going to give you an example of that. For equation in two variables, you're looking at basically an equation that has two variables. So let's just put an example down and let's write, y equals 4.2x. That's all that means, is that you have two variables in an equation. Okay, so now let's look at the first example. If you need to, pause the video and make sure you fill in solution set and equations in two variables on your notes. Okay, for the first one, we have these ordered pairs, and we want to know which of these ordered pairs are solutions to the equation y equals 2x minus 1. So basically, which of these ordered pairs, when I substitute in the domain value for x, and the range value for y, does it actually come out to be true? Well, then we have to try this. So the equation is y equals 2x minus 1. And so I'm going to use each of these ordered pairs and substitute in. So I want to know if I put in 1 for y and I put in 0 for x and I follow the order of operations, is that going to make those equal? Well, 2 times 0 is 0. 0 minus 1 is negative 1. Is 1 equal to negative 1? No, that's false. You can put F or you can just put an X to let us know that. Try the other ones and see if it's true or not. And so this is what you should have gotten after you substituted in each of the values and work through. You should see that 2, 3, and 3, 5 are the only two that are actually solutions for that equation. It's the only time where you put in the x value, you follow the order of operations, and you actually get that same y value. So now you need to try one on your own. And so the one on your own, your equation is y equals negative 3x plus 2. And again, I want you to substitute in each x value and see if you get each y value and which of these are solutions. Which of these are true when you plug them in? Pause the video, substitute in those values, show your work, you have plenty of room, and list the ordered pairs, if any, that make this true. Pause the video now and work that out. So if you substitute in each x value and each y value, and I do want to see that work on your paper for each of these, you should show that when you substitute in 0, negative 3 times 0 is 0. And then 0 plus 2 is going to equal 2. So this is a solution set that makes it true. And then also show that if you do negative 3 times negative 2, negative times negative is positive, so that's going to be positive 6. And positive 6 plus 2 is going to give me that range value, that y coordinate of 8. So these are the only two that make it true. All right, flip over and let's work on the next one. Okay, for example 2, we are given the equation y equals 3x, and we're given the domain values. So they're telling us what x's they want us to put in, and we have to solve and find y, and we have to make an ordered pair. Okay, and theoretically, once you get the ordered pair, you would actually graph it. But for the example I'm doing with you, we're going to substitute in. So y equals 3 times x. So for every domain value that they gave me, I'm going to substitute that in for x. 3 times negative 2 is negative 6, and the ordered pair should be the x value you put in and the y value you got out. Okay, so pause the video now, complete the chart, show the work, substituting in for each x, getting the y, and writing the ordered pair. Pause the video now and do that. So your table should be complete now, and when you substitute in each of those values for the domain, and you multiply, you'll get each of those ranges, and then you write the ordered pair, and then you would go and graph it. That would be the next step. For our purposes, we're just going to fill in the table, but you're going to do an example. You're going to try one on your own now, and for that one, you are going to, you see down here, substitute in each of these x values, domain, and for x, multiply times -4, get the y, and graph it. Do that now. So these are the ordered pairs you should have, and you should show your work of when you multiplied each of the x coordinates in the domain into the equation for x times -4. These are the outputs, the range, the y value you should have gotten, and this should be graphed on your paper. Okay, that graph should be complete. If it's not, pause it and graph it now. Okay, when you're done, we're going to move on to the next example. Okay, for example 3, for this example, you're actually, you have an equation with two variables, as you can see, we've been dealing with before. It may look a little bit different, but there's still an x and a y, and you're given the domain, so you are given the x value. You, again, need to substitute and solve. It's going to be multi-step, right? So like for the first one, you're going to have to do 4 times -2. And then you have this 2y plus 8. 2y equals 8. You're still going to follow the order of operations. You're going to multiply those. And I'm going to work in this space, but you should work it out in your notebook or on a separate sheet of paper, because this space should just be where you're doing the work. So let's imagine you're doing this in your notebook. So get your notebook out, pause the video if you need to, get a separate piece of paper. I'm just going to go ahead and do that here. So I've got 4 times -2 plus 2y equals 8. Now I'm going to follow the order of operations, and I'm going to do everything I need to do to get the y by itself, because I'm trying to figure out what is the y going to be when I put in -2 for x. So, okay. 4 times -2 is -8 plus 2y equals 8. Well, I want to do everything I can to get the y by itself. So I need to undo what I'm doing to it. Well, I'm multiplying it times 2, but first I need to get rid of this plus -8. So if I'm adding -8, you could rewrite it this way. You could say 2y, minus 8 plus -8 and minus 8 is the same thing. So by commutative property, I just switch the order. If that helps you, you can do that. If you don't need to do that, then do what needs to be done. And what needs to be done is you need to be adding 8 to both sides. If you have plus -8, the opposite of that is, instead of subtracting 8, because adding a negative is the same as subtracting, you need to just be adding 8 to both sides. You know how to solve a two-step equation. We've done equations. So when I do 8 minus 8 here, this goes away, which is exactly what I wanted. But now I have 2y equals 16. And now to isolate the variable, now I'm going to undo the multiplying. I'm going to divide by 2, and y equals 8. So that's why you definitely need another piece of paper for this. So then go back to the table, write 8 here, and write the ordered pair. And you see that there's graph paper underneath. You know that once you get all your ordered pairs, you're going to be graphing it. So if you want to, you can go ahead and place a point there. So you need to pause the video. You need to work through, just like we did here, but for all the other domains. When 4 is negative, when x is -1, when x is 0, when x is 1, when x is 2, fill in your table and graph your points. Pause the video now, work it out, get your range, get your ordered pairs. You can check, and then you can graph it. Do that now. So check your values here before you graph it. Remember that the original equation was 4x plus 2y equals 8. So as you're solving it, make sure you're always setting it up to equal 8, and then you're multiplying, subtracting, dividing. And these are the values that you should get. So if I get negative 4 here, that means I'm going to be adding 4. 2y is going to equal 12. Divided by 2 is going to be 6. You should have negative 1, 6. So if I do 8 minus 0, when I do 4 times 0, I get 0. 2y equals 8. 8 divided by 2 is 4. You should have 0, 4. You're going to be subtracting 4 this time. You were adding 4 this time because you had a negative 4. So the opposite was to add. But now you have a positive 4, so the opposite is to subtract. So now you're going to have 2y equals 4. And then when you divide by 2, it's going to be 1, 2. 8, when you subtract 8 minus 8, it's going to be 0. And 2y equals 0. Y is just going to equal 0. So these are the ordered pairs. These are relations you should have. This is your solution set. And then you need to go ahead and graph it at the bottom. It's already numbered for you, so just place those points and they all should fit perfectly. Do that now. Okay, so this is the one for you to try completely on your own. You should set up a table, and your table should look like this. You should put, the x values that you're going to put in. Have a little column for x. And you don't, again, have room to do this on this paper adequately, so you need to do this in your notebook or a separate sheet of paper. Make an x column. Write these numbers down because these are the x. In the middle column, write down your equation. Substitute in each value for x. Solve, get your ordered pair, and graph it. Okay, do that now. Pause the video and work through this now. Okay, and this should be the solution set that you get. If you multiply negative 3 times 3, you're going to get 9, negative 9. When you have a negative 9, you're going to have to add that to the 12. So it's going to be 6y equals 21. And when you divide 21 by 6, it's going to equal 3.5. If that was a little too fast for you, I can work it out for you, but just go back and check your work. Because if you get negative 3 times 3, it's going to be negative 9. In order to bring it to the other side, you have to add 9. That's going to make that 21. And 6 doesn't go into 21 evenly. It's going to be 3.5. Negative 2 times 3 is negative 6. You're going to be adding 6 to 12, which is going to be 18. And when you divide 6 into 18, it's going to be 3. Negative 1 times 3 is negative 3. And since it's negative, you're going to be adding it to this side to undo it. So it's going to be 15, and 15 divided by 6 is 2.5. 5 times 3 is 15. When you subtract 12 minus 15, it's going to be negative 3. And then you're dividing 6 into 3. So it's going to be negative a half. 7 times 3 is 21. 12 minus 21. Anybody? Is that 9? So 6y it equals negative 9. And then you're going to have to divide by 6, which is negative 1.5. So make sure you graph those points if you haven't. Do that now. There's space for halves. You just, it's not going to be on a point. It's going to be in between. So if you have like negative 3 and, what is this, 3.5, then it's going to be negative 3 and then like between 3 and 4. You can do that. That's fine. That's 3.5. So plot all the points if you haven't already, and then we'll do our last example. Okay, do that now. Okay, this one is a little bit different. So to me, that makes it fun, but I'm a math teacher, so I guess stuff like this is just fun to me. But, so in all the examples that we've done, we've been given the domain, we've been given the x value, but now we're given the range. So they gave us the y value. So you actually know what this is going to equal to, but you don't know what x makes it equal that. So for instance, fill this in. It's going to equal negative 3. It's going to equal negative 1, 1, and 3. And what x makes that true? So negative 3 equals 2 times something minus 5. And again, you're not going to have enough room on this sheet to work it out, so go to your notebook, extra piece of paper, let's work this out. Pause the video if you need to, otherwise I'm rolling on. And I want you to be working this out with me, so seriously, on a separate piece of paper,